There we go. You are
Yes,
live.
looks like we are live.
You are live.
So let's see how we're doing with attendees.
Probably take a minute or two.
Oh, let me. Yeah, there I am. No, I'm not. Video. Oh, there I am. Okay, it's going to take a couple of minutes to let people come in.
Okay, we got 14 live.
All right.
Anurag, Bill, Alan, quickly. Thomas, Fabian, Dylan, and Edgar so far.
Good. So, folks, we're going to give, first of all, welcome, and we're going to give everybody a couple of minutes to sign in, and so we don't, so the train doesn't depart, and people have to chase the caboose. So let's wait for a couple of seconds. Yeah, the count is growing quickly, so let's wait a little longer.
Ashok, welcome back.
Oh, Ashok, I don't, doesn't ring a bell. Ashok.
How about Juan? How about Juan Aranda? Does that ring a bell?
I know Juan Emilio Aranda, but
yeah, must be a different person.
Must be a different person.
Yeah.
Osvaldo, Fabian, hey, lots of folks from the Spanish-speaking world. Would you be so kind to just let us know while we wait for a couple more minutes for everybody to let us know where you are hailing from?
Where are you from?
I know that Juan Emilio is in Denver. Ashok was in Ohio, right?
Florida, right?
Florida? Okay. So if you want to take a second, let us know where you are dialing in from.
Yeah, Alexander, where are you from? Voronin.
Yeah, be interested in hearing some of that. In the meantime, welcome. Yeah, the numbers are increasing, so welcome everybody. Today we're going to discuss a topic that's very near and dear to our hearts, because the way we present ourselves to the world is we are the mixed model line design guys, the mixed model material management guys, right? Give us your factory, we will redesign it in mixed model line design into a mixed model line. Give us your materials organization, we will design it to support a mixed model line. But what sometimes gets lost in translation is that, okay, so you're the guys who design the lines. Yes, but as a matter of fact, I had this conversation just a few minutes ago with a new client, a new prospect, and that is, if we only design the line and leave you with it by saying, hey, here's the line design, good luck, the job is not done. We need to figure out with you, understanding the processes, the work content, the takt time, the changeovers, in all the data necessary to design line, we need to figure out how to use it. And the how to use it is then to be repeated every single day in the form of a production plan. And that is what we want to discuss today. Line design, we're going to call that a fait accompli. We're not discussing that, relitigating that. The line exists. Now we're going to talk about how to use it, and a very narrow band of that is using simulation modeling as a production planning tool. So that's the goal for our webinar today. And we do have some recommendations. We do have a video showing you the utilization of our simulation modeling tool. And our simulation modeling tool is a simple tool. We're not in the market competing with ProModel, even though we say that, I guess we are. They make something difficult to use that'll take you a year to get trained on, and ours is a simple one that we can train you online in 4 hours how to use it. But then again, what they can do with their model, they can simulate the traffic in the state of Ohio. We can't do that. We're not interested in that. That's not our business. So with that, looks like we are 5 minutes into our time. What do you say, Richard?
Okay, let's get going. Let's start with something we haven't tried before, but I want to give this a test. We have some polling questions. So let's start out by just flashing up a poll. You should see it on the right side of your screen. And it's just asking you the question, are you currently responsible for production planning in your company? Because I imagine that some of you might be, but maybe many of you are, here to learn and, and find out more about the subject, but it's not really your job. So can you go ahead and just click yes, no, or sort of, indirectly in this poll? And meanwhile, we'll get started on the presentation. All right, so let's launch here.
Yeah, launch there. And by the way, sorry, I haven't acknowledged all these great places you folks are dialing in from, and we're so grateful that you just spend your time, in some cases your nights with us. So we're gonna try. We promise we'll do our best to make it worth your while. My goodness, from all over the world. So this is pretty cool. Holy
okay.
cow, there are 2 Juan Arandas.
2 of them, incredible.
Yeah? Nah, I don't think so. Well, I have 2 messages from Juan.
One for each year.
Sorry, folks. Inside joke. Go. Oh.
Okay, so let's get going. Mixed model planning is the title, and most of it is going to be presenting the background and the theory and the strategy, and then we'll have a chance to do an actual demo using our lean design simulator, using our discrete event simulation modeling tool. But let's get started here. Let's see if I can position ourselves so we're not quite so obstructive.
We're not intruding.
How about that? There we go. All right, so the agenda for this webinar, quickly, we want to review the strategy of planning for a mixed model environment, which is not a minor detail because, as you can appreciate, if we have many different models with different work content, then the mix, the products we want to run today are going to have an impact on what you actually are able to achieve because the work is going to change, the work content is going to change. So the planning becomes even more important in that kind of environment. It's not simply a matter of quantities, but it's a matter of mix. So we're going to review that. Now we have a couple options all the way from simple spreadsheets, Excel spreadsheets that you already have access to, I'm sure, to some modeling options. As Gerard just mentioned, however, we're not going to be trying to get into the more sophisticated artificial intelligence planning software or whatever else might exist out there. I'm sure there's some great, amazing tools, but we don't know anything about them for starters. And second of all, that's beyond the scope of what we're trying to address here. So primarily what we're trying to do is get a handle on a daily basis as a planner, what is our expected throughput based on a certain volume of orders, of customer orders, and related to that, what's our level of utilization? That's utilization of our resources, our equipment, our machines and our workstations, but also utilization of our workforce or our people. We need to be planning for that as well. It's not just good enough to achieve a throughput and have massively inefficient use of our resources. And then the third thing, which is, I think, an interesting topic we'll spend some time on, is Kaizen. So can we integrate our planning efforts with the opportunities for improvement? Because you're going to run into roadblocks, bottlenecks, opportunities for improvement that you can't change as a planner. You won't be able to do anything about it, but maybe in the future, something could be done in the form of a Kaizen event or a process improvement project. So we'll be addressing that as well. And then, of course, I'll be taking over and driving to show you the Lean Design Simulator, our simulation tool, and how we would use it to help us in these endeavors. Okay, anything you want to add, Gerard?
No, that's it. All good stuff. Let's get going with the contents.
Okay.
So, our goal, as I mentioned, we're going to start from the standpoint that we do have a line design, and the line design is a valid line design. That means number of resources can support tag time, and tag time has been calculated on the basis of the mix of models. So once we have that line, we understand the resources. We're basically process by process putting in place a certain amount of resources to be consumed by the daily demand. The probability that demand day to day will match the design volume is the design mix and volume is very, very low. Now, some of you might have the fortune of having a very long portfolio, very large portfolio, and you can pick and choose and assemble a mix that closely resembles your design mix, but it is unlikely. For most of us mortals, that is not going to happen. Then the question becomes, if I have this mix, I have this line, I'm not going to redesign the line every day, right? I have this mix, which is what the customers want today. Is this mix achievable within the 8 hours or 10 hours the line was designed for? And if it isn't, then what? Can we do that with overtime? That can be tested, right? Now, that time window can be defined in the simulation model. Is the line resourced optimally, or through simulation model, we can identify the need for additional resources, right? And for this, we're going to have two stages, the design stage and the planning stage. And also, and finally, is figuring out set of sequencing rules for sending that mix of product down the line in order to first achieve the goal of the line, or in some cases, figure out if we're going to go over, going to go under. So that's our goal, understanding with our line design in place, what are the daily planning mechanisms that we need to go through, or daily planning features that we need to go through to make this line viable and valuable for the company. So that's what we're trying to achieve today.
Very good.
All right, so all we're going to say today about the design stage is what you see on the left side of your screen. First of all, we are big advocates of using simulation modeling. Times are changing, folks, and the design of a mixed model line based exclusively on static calculations from a spreadsheet, that's becoming old school. It's like wanting to have all materials on Kanban. Old school. We're not doing that anymore. We're progressing, right? So a line design that we propose to test with simulation model is not that it happens every day. This idea that we change stacked often, that's nonsense. If anything, once a year, right, we rebalance the line because changes in mix and volume. So it happens infrequently. Must be tested using simulation model, right? And from the moment we finish that line design to the moment we bring it live, in other words, the moment in which we see the impact of our decisions, it doesn't happen immediately, right? And in some cases, the data may not be available to know how well we have done. So that is what happens at the design stage, is you design and you test and you balance on the basis of the best data available. And in some cases, you're going to have to make some assumptions based on estimates. On the daily management side, the line is live. Mix and volume changes every day. So this line, this value stream, what you have to do is to run it and make sure that, first of all, can achieve the design objectives, of which the preeminent one is, can I get the volume, right? Can I get my throughput, right? And that throughput, when you dig deep into this, into that throughput, you're going to see that it's not just widget, 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 are the products that you build that have different levels of configuration, different levels of complexity, but they do conform to the rules of mixed modeling, so you can run them on the same line. And sometimes some mixes, some days, guarantee, some mixes are not going to let you reach the goal of the line. So you need to be prepared for that. That could be okay if that is how you run your line, if that is your policy, right? So this daily rate can vary as a policy decision. I'll tell you, for example, when we were discussing this, as we were preparing for this webinar, the folks at Toyota, they have a set number. That number, they will reach it every day, come hell or high water. That's how they run their lives, right? So for them, it's the volume. You reach the volume. In some other cases, what you're not going for the volume, you're going for the consumption of resource minutes. So today we're going to focus on the right-hand side. The line has been designed. Now we get mix and volume. Can I run this mix through the line and get my objectives? So let's move on. So can I use a spreadsheet? Well, yeah, of course I can. And we use it all the time. We use spreadsheets to design the lines, to do the standard resource calculations. It's almost impossible to start with a simulation model. I guess some of you might be able to. We can't. We do our static calculations, and from there we feed the simulation model. So absolutely we do use a spreadsheet, but now the question is not the spreadsheet for line design, it's the spreadsheet for daily planning. And yes, we do that too. We use the same spreadsheet, but we're not recalculating takt time. Please don't say that, because you're going to make me cry. We use the same spreadsheet because you need all the same times, right? And we need the product offering. And what you do is you change the volume, and you have your resource calculus at the bottom, and you see if you consume those resources. The good news, you can make this happen pretty quickly. I can take a resource calculation spreadsheet and turn it into a planning tool in a day, right? And test it. So from the standpoint of the benefits, that's the benefit. It's easy to do, and you can quickly do your analysis. And for those of you who are proficient in using macros, you can use the macros, right? The minus is static. It doesn't capture the interdependencies. It doesn't capture the variability, and the variability, it does matter. So it is a very good option. We believe that modeling option, simulation modeling option is better. Why? Because it captures both interdependencies and variability, and it gets you closer to the real world. You cannot expect that a person will work always exactly to the standard. A standard is an average. And some folks are faster, some folks are slower. In the morning, we're faster. In the afternoon, we're slower, etc., etc., etc. Right? And you could run what-if analysis like that. When Richard shows you the simulation model, a day runs in seconds, right? Seconds. And you can immediately bring the resource, the results spreadsheet, and look through and see where the blockages are, where the wait time is, and the utilization, and very quickly make decisions. You can run in an hour, I don't know, 20 simulations with interpretation time. So those are all the pluses. On the less than plus side, the minus side is the fact that there is a steeper learning curve, not with hours. And again, not with hours, because hours is a simple simulation tool. If you want to learn Pro Model or Sim Factory, yes, you're looking at hours upon hours upon hours, and I'm talking in the hundreds to be able to be proficient in that. So today, I'm going to be talking modeling.
Okay, so just to summarize kind of what we've discussed so far, we have two stages. We have the design stage, we have the execution stage, or the management stage. So the image that we're building in our mind is we would build a model, based on mixed model manufacturing. When I say model, I mean simulation model. And we're going to rely on the data that we collected when we did a static design. And as a matter of fact, I would say 90% of the data that we used in the static phase of a design transfers over very nicely and seamlessly to the creation of a simulation model. But we're going to need to do that. And then we're going to test our model with, at least at the beginning, we may not have actual performance data, right? So we have historical data, past data that we can use to test our model, make sure it's working and achieving the results that we set out to achieve, which are throughput and productivity and utilization, et cetera. Now, once we're in actual production, so we're building products then, the plan here, the vision, is to be able to test our daily production plan, or it could be a weekly plan, whatever time frame you care to choose, but we're going to attempt to test that or validate that plan using the model and not the original data we used to design the line, but the current data, right? Today's data, today's mix. And we're going to run it. And if we're not achieving the result we need in the model, then we're going to take some steps with the line balancing tools that we'll go over with you in a little bit. We're going to apply some strategies to improve the performance of that scenario. So that when we release a production plan to the factory, we have a higher level, not guaranteed, but we have a higher level of confidence that that plan is actually achievable based on that mix. Right? So we're not changing the takt time, and we're not trying to build what we actually designed to necessarily. We're trying to build what the customer wants to buy. And chances are 99.9% certain that it's not going to be the same mix that we used to originally design it. Therein lies the challenge. So that's the vision that we're going to pursue in this methodology that we'll share with you.
Similar conversation to what we have when we discuss balancing. We always say we're going to balance on paper during line design, and then we're going to balance live when we bring the line live. Those 2 points. By adding simulation modeling, we put in the middle one extra point, which is going to serve as a buffer, protection against finding surprises when you bring the line live. And that's exactly what we want to do with simulation modeling for planning. You have a plan that, by all intents and purposes on paper, works. When are we going to test that plan? When we feed it to the line. We're talking about putting something in the middle, and that is, you have your production plan, run it through the simulation model. Does it work? Yes. It doesn't work? Oh, let's go back and figure it out. So, one thing that we're beginning to see, because again, the world is changing. We're asking more of our factories than we used to. When in the past, for a factory making 20, 30 tractors, that was a big deal. Now we're asking for a line in a building pretty much the same size. We wanted to make 50, 60, 80, 90 tractors. And now, particularly now, the world has gone bonkers, right? Because there is enormous pent-up demand, and we're beginning to see some takt times. How the heck are we going to do this, right? And we're helping clients. We happen to be right now in the space of big product. We're doing a lot of big products, right? In the big product world, when you start looking at 5-minute takt times, and I mean big product, the size of half a shipping container, that big I'm talking about, right? And when you start looking at the 5-minute range there, holy cow, because you have to remember that you have to move that product to the workstation. You have to move that product out of the workstation 1 minute on one end, 1 minute on the other end. And you are left with 3 minutes to do work. And then you have 1 more minute to acquire parts. Now you are left with 2 minutes to do work. So we are sharpening our pencils a lot more in this new world. And for that, we want to make sure that we mention this, that in your simulation model, that if before you let things like operator move time or part selection time or product move time, you embedded that into the work content time. Now I'm going to ask you, especially for large product, if you're making this thing, this mouse, no, don't worry about that stuff. But if you're in the big product world, we're going to ask you to look at those to make sure that we include those in the simulation model. By the way, our simulation modeling tool does allow for the inclusion of these times, and treat them separately, because those could make the difference between reaching throughput or never reaching throughput. Because how come we cannot do 5 minutes of work? Well, because you're only left with 2 after you subtract in, out, and materials. So please keep these in mind, especially if you are in the large product world.
Okay, so the primary question we're trying to answer through this methodology as a production planner is, on a day-to-day basis, is this plan actually achievable? So if we plan to build 100, can we actually get 100 within normal working hours or planned, additional time if we decide to do that? So within an effective work minutes window, so we have a certain amount of time to do work, can you complete the number of units that we want? So when we get an answer to that question, there are several possibilities. One is, yes, we can. Then the follow-up question is, well, can you do more than that? Because you might be building an easy day, have products with lower work content, and what you're planning to do may be less than what you're able to do. And you can add additional products to the schedule. Great. That would be great to know ahead of time. Now, if it looks like you can't make it, can you make it with some overtime? And I think Gerard touched on this already, but Toyota Material Handling, one of the places that we spend a lot of time, has a policy of hitting the same number of units every day. But of course, when the mix changes, that may not be possible within normal working hours. So they have a negotiated certain number of hours with the workforce that they can be asked to stay to hit their numbers every single day. You don't have to do it that way, however. You can run a different number of units every day. There's no law against that. Now, if you can't meet your goal and you don't want to run overtime, can you improve the throughput by changing the mix? Now, again, this depends on your situation. There are companies that have the luxury of being able to change the mix because they have enough lead time from their customers. In other words, they can change the order, they can pull in orders, they can push back orders and still not affect customer delivery. If you have that luxury, congratulations, you're lucky. Now, there are other environments where you don't have the luxury because you don't have the lead time from your customer. Basically, when you get the order, you have to take action. One of those examples is the eyeglass industry that puts the lens into the frame. There are a lot of labs around the world that do that, but typically the customer is not going to wait 2 months to get their eyeglasses. So when they get the order, they got to hit the ground and start doing the work. So the ability to manipulate your production plan in that kind of environment is much less. And then you have to rely on resources, right? Having enough resources to adjust to those variations.
On that one, Richard,
yeah.
One of our clients for whom we designed 14 plants around the world in the hearing aid industry, and that's pretty common on these medical devices, especially the ones that you have to compete not only on price but most importantly on lead time, right? Hearing aids. We have designed 14 plants around the world on hearing aids, and here is the production plan. Go to your door, pick up a gigantic bag that looks like a trash bag that in their case DHL brought in, cut it open, dump the envelopes on a table. That's the production plan. That's what it came today. Now we need to figure out how to make it. And we make it today because the lead time is less than 3 days. It needs to be back. It needs to be shipped out in less than 3 days. So those folks, no, they cannot manipulate the mix. The mix has been manipulated for them.
Yeah, pretty much the eyeglass industry is same thing. So if you can't meet your daily production plan, another option is can we improve our throughput with additional resources? But those resources typically are people. You don't have a lot of flexibility from today to tomorrow to change the line layout or to be rebalancing the line or doing things like that. But you can probably pull some people and add it if that can help, and if there's a place where they can work, of course. Or have floaters that are going to be available to step in on certain units to help get them through the station if they're on the high side of the work content. So there are things that we can do, of course, but we want to have an achievable plan as far as we know before we release it to the factory on a day-to-day basis. And we'll show you how we propose that you do all these things here in just a minute.
Richard, as you change, result of the first poll is that 75% of the people attending are directly or indirectly related to planning. So
yeah, good. Well, we're the right people.
Preaching to the choir here. So.
That's great.
Thank you, folks, for answering.
Okay.
All right. So we did our resource calculations. We figured everything out, the balancing. Right? And now we're going to run the line tomorrow. Normally it's not for today, right? We're going to run the run tomorrow and in the days after, right? So I have a mix. And the first thing I'm going to do is run that mix through my resource planning and figure out if I have enough resources to run the line, right? And normally what we will do is to under-resource the line, meaning leave holes in the line for flexing to take place. So the number of people needed is going to vary depending on the volume and mix, right? We're going to need more labor minutes if we send the more complex products down the line, the ones that require more labor, the more fully loaded versions, right? So in some cases, and this is what we always strive for, is we don't want to have a value stream that's fully staffed. We want to leave holes in the line for people to flex. For those people, are they cross-trained, right? And are there certain processes that act as barriers? I am right now working with a client where we have a quality department embedded in the middle of the line, and I can flex up to that department and I'm going to bounce and come back. I cannot flex into that department because of how that company policies work, right? So flexing requires cross-training, and not just cross-training, but also how to flex. Flex does not mean to move around looking for stuff to do. It means moving with the work up and down the line, meaning to subsequent stations or prior workstations on the basis of demand signals, either the in-process Kanbans or the workstations. We have a 90-minute dedicated class to flexing. So if you're a member of the Lean Design Studio, please go ahead and check out that specific class on flexing. In flexing is one of those underutilized resources. It sometimes is hard for folks to understand it, and I don't really know why. Sometimes I think is open to confusion, and it is a great resource. It's something that we should do a lot more. And I know my clients do it. We design that into the line, because if not, you're just leaving 10-15% productivity on the table. So how many people you need today, and whether or not they can flex, and whether or not you design your line with the ability to flex.
Yeah, so there's an author and lean consultant named Gordon Guerin, and he's written a book on flexing, basically. He called it, what did he call it? I can't remember.
The self-balancing line?
Self-balance, yeah, there we go. Self-balancing line. That was his term for it. But he said that in his experience on his projects, he's never seen less than a 30% productivity gain when you can get your workforce to flex, and they have places where they can go, right? Now, if your policy in your company is, I need a worker at every station, every day, then what you're leaving on the table is a potential productivity gain, because if you have a lighter day, those people are not going to be fully busy, right? They're not going to be working all the time. And there may be other reasons why you want to have someone at every station every day. I mean, it's simpler, right? you just fully staff the line all the time. But what companies that have that policy, like Toyota Material Handling, they have a plan in place so that if you don't have actual work to do as a worker, now we're not saying half a day, we're saying maybe you have an extra minute, right, available. Then they have things that that these people can do to quote unquote add value, but they're not adding value building products. They're adding value cleaning up their workstation or organizing their area, that kind of thing, like a 5S effort. So we're saying to you that you do not have to staff a person at every station. And if you staff correctly, then you can maintain a high level of productivity with your workforce and still get the same throughput, right? That you
Bottom
need.
line, we're very, very big fans of flexing.
Yeah. Okie doke. So final question, I think here, or one of the final questions. No, we have a few more questions. But what are the constraints? So one thing you want to know as a planner is where are the obstacles or the bottlenecks going to be, say, for tomorrow or for the upcoming time period? And that could be one of two forms. You could have a station that's going to be overloaded, overburdened tomorrow. That becomes a physical bottleneck. Or you could have certain units that need to be monitored closely, maybe even to the point, and this is, again, companies do this, of putting a flag or a signal on that unit, and that visual signal, or maybe a cone, like a traffic cone, orange traffic cone, you put it on top if it's a larger product. And that's a signal that that is a higher work content product that needs attention by not only the people at the station, but also maybe floaters or team leads or assistant team leaders that might be required to step in and follow that. So you as a planner then would have that knowledge or be able to see that through your simulation model results and communicate that basically to the floor so that we can make sure that those kind of units, those troublesome units, high work content typically, are paid attention to and are addressed as they go through the line, right? So you can see that in the simulation results because it's going to show you every station and every operator, actually, their percent utilization, right?
We want to use simulation modeling also for future Kaizen opportunities. You're going to see when Richard runs the model that we're going to be pointing out to you the workstations that are constraints, or which workstations are normally blocked or waiting, right? The simulation model is going to point that out. What are we going to do about that, right? So some of what we can do is to rebalance. How do we rebalance? We follow the balancing tools. We're going to be bringing those up in just a minute. But that is a perfect opportunity to use the technique of Kaizen or the methodology of Kaizen to apply the balancing tools, right? In that way, we can reduce or relocate the work, or in some cases, find that automation is necessary. Again, with one of my clients, we realized that we needed to add DC torque tools to a workstation to bring him into TAT. If not, we just couldn't. So we did add the DC torque tools to adjust the torque the torque value of certain bolts, right? Can we relocate the work or change the layout? That's not something we do day to day, but the daily use of simulation model is going to be pointing out those constraints And if they become a recurring theme, that is something that needs to be handed to your Kaizen experts or your director of continuous improvement or the supervisor, whomever is doing Kaizen for that specific process or workstation. And again, it's also going to point as to whether or not flexing is being used. One important thing to know is that nobody was born knowing flexing. Unless you train people on flexing and you hold hands for some time, it's not going to happen. You need to be there, you need to train people, you need to teach them, right? And then just trust them and let them go ahead and flex. So using simulation model to point out Kaizen opportunities, again, something that we're really not going to dig deep into that. We just want to mention the fact that what do we do if I see that constraint every day? Then this is probably your opportunity to apply the balancing tools through Kaizen to that specific workstation or process.
Okay. And what could happen with this flexing issue is that if you see on a day-to-day basis frequent low utilization of operators, and yet you have a policy of putting a person at every station every day, then that raises the flag for the opportunity in front of you for flexing.
And the simulation model is going to tell you, operator by operator, is going to tell you utilization.
Yep.
And you'll see it.
Okay, so let's get into it here and show you an example of how this might work. I like the term model-based planning. It sounds sounds like a great buzzword. For some reason, it appeals to me.
Let's put it on Instagram. See if we're going to.
Yeah, trademark it. Trademark it, Amazon. Okay, so here we go. I'm going to walk through this now. One of the things, by the way, that I'm trying to avoid here is reducing variability. And whenever you're doing software demos, there's this risk that something can go wrong. And so what I've done, I got up early this morning and I recorded the software piece of it that I'm going to show you. So you'll be watching a video. I'm wearing the same shirt, so you may not know the difference here, but I did record it and made sure that we weren't going to have any hiccups. So here's the scenario. We're building in this scenario, in this line, we're building scale models of these boom trucks. We actually worked with with companies making these, so we have some knowledge of these. But these are models; they're high-end models, and I'm just referencing here a past client of ours called Pacific Miniatures, pacmin.com. They make high-end, expensive models of airplanes, all the way from desktop models. Like if you buy your own Learjet, you want to have a model of that sitting on your desk with your own tail numbers and everything, colors are all exact.
Who doesn't have a Learjet?
Yeah, exactly. We're working on it, right, Gerard?
Yeah, right.
Not yet. So Pacmin does that. So these companies exist that do that kind of work, and that's what we're talking about here. So we created a static design. We have 10 models, believe it or not, and we just tried to keep things super simple. So we just named them with letters. And we have some target volumes, 72 in total per day, but with a different mix based on our past history and anticipated future demand. And then we have times in minutes, and we did some calculations that you might be familiar with as a lean professional. We calculated takt time, and then we calculated resources, and then we rounded up to 4 stations in the main line and 2 workstations in the boom feeder line. So we did, again, this is Excel-based or spreadsheet-based, but it's going to get us very close to our final design. And then we created a rough layout, a conceptual layout. You'll notice the takt time for both is the same because the feeder line is 100% option. So every truck requires one. It's not an optional feeder process. It's going to be consumed in station number 2. And so a very simple layout looks something like this. Again, this could be much more complex, but we're trying to keep things, reasonable here. So in summary, what we have is 72 units per day is our design target, 10 products, 6 workstations in total. The times are 21 minutes on the main line and 9.5 in the feeder. And we balanced the work across these stations. We didn't try to be too sophisticated. After all, this was a made-up example. So we just distributed the work evenly across those 4 stations by product, right, by model. And what we want to test for then is throughput. Can we achieve the number of units that we want, and the utilization or productivity, labor and station utilization. All right, so that's our goal. Now I'm going to run a video. Let's cross our fingers, and I'm going to show you the actual software and doing some of this work. So I'm going to start the video, and okay, let's get into a demo of the actual tool itself, the Lean Design Simulator. So we've created a model. Let's assume at this point that we've created a model of our mixed model line design, and we've tested it. We've optimized our design. We've gone through all of these steps already, and I just want to show you the end product then of the model that we're going to use going forward. So here's the data file. We're looking at the data file. This is built in Excel, and we have a main line and a subassembly or a feeder line. So we're defining the 2 main flows, and in terms of resources, we've got 4 workstations on the main line and 2 feeder workstations, and then we have 2 labor classifications, the final assembly and the feeder or subassembly operators. And we've kept those separate. And then we're defining the flow here, so we have our feeder line, and that connects to the second workstation on the main line, and then we have 4 mainline stations. So again, this is a pretty simple example. It can be much more complex, obviously, than that. And then we have 10 products. We've just tried to keep it simple and just named them with letters. And then within this model, if you have a subassembly, similar to kind of a MRP philosophy, you have to give this subassembly a part number as well. So product A will consume subassembly A, etc. So all very straightforward, and we're going to build the subassemblies in the subassembly flow, and we're going to build the main product on the main flow. Now, process times, we have different times for each of these models. So this is where we document the subassembly times and the mainline times. These are all in minutes, and how many people are required to do that work. So we could have, more than one person allowed, if that's the case. So we have times for each of the 10 products, and you notice they're not all the same, so some are harder and some are easier in a typical mixed model fashion. And then we've tested a sequence. We've started with a very simple sequence. We're just trying to build each of the products one after the other in sequence. And this is what we're using. This is different from the mix that we originally used, but we're going to use it for this mix for testing purposes and make sure we can meet the objectives that we've set out for ourselves in the design. So let's run it with this sequence and see what we get. So I'm switching over to the Lean Design Simulator, and I'm going to choose this file. It's called Mixed Model Planning Demo. I'm going to open it, and we can validate it, but it will be validated when we simulate it in any case, so we don't really need to click on that button. I'm going to allow a warm-up time of 30 minutes. That's to fill the line. If we had no warm-up time, then there's going to be a delay for the products to reach the end of the line, which is going to throw things off a little bit. So we're going to warm up for that amount of time, and I'm going to run it for the same amount of time that we used to design the line. Now remember, our design goal was 72 units within the 420 minutes, so we'll see what we get. We want to be there or maybe a little bit better, and we are. So we're at 76. So this confirms then that we have a model that, at least with the mix we're using, will meet our objectives, our original design objectives. So now let's go back and let's go back to the Excel file and let's change the sequence. And what I want to do is demonstrate for you the range of actual performance we can see as the mix changes, which is what is generating the whole purpose of this webinar, to demonstrate to you that unless you test, your sequence, test your production plan ahead of time, then you may not be aware of what's going to actually happen. So I'm going to change the sequence here to a very simple example. I'm going to take the hardest product, which I believe is H. We can check that by looking at process times. But if we look at product H, we have 7 minutes in final assembly, and a quick visual scan tells me that this is the highest work content product. So we're going to just try to build the H. We got a large customer order for H products only, and we're going to try to run those. And the way we would do that is we would just simply, without having to recreate the whole sequence file, I'm just going to rename that previous one that we just ran, and then rename this one back to sequence. And the simulator is going to look for the tab that's named sequence and use that one. All right, so I'm going to save this, and then we'll go back to our simulator, and we're going to select another file. Actually, it's the same file, but we made changes to it, so we have to reload it, and we're going to simulate. Fix that. Okay, so let's run it and see what we get. Run. And we get 59 units. So this is not what we want, right? Remember, our goal was 72, I believe. So this gives us an idea of the lower range that we can expect to actually see. Now let's try one other thing in this demo. Let's go back to our Excel file, and let's change this to the lowest work content product, which was the I product. And again, we can do a quick eyeball on the process times and look at that. But I was 4.2 minutes on the main line. Sorry, 3.9 minutes on the main line. And that's the lowest one, looks like. Okay, so we're going to save this file. We're going to go back to our simulator. We're going to select another file. We're just going to reload our data file. And we're going to run it again with the same parameters. So 30 minutes of warm-up and 420 minutes of runtime. And go. And 97. So what we see here then, what we're trying to demonstrate to you is that as the mix changes, the number of units you can expect to get in this mixed model environment is going to change also. So if we only wanted to run the I products in this example, we could get up to 97 within that same period of time, the 420 minutes. And if we were trying to run the harder models, we would get potentially as low as 59. So as a planner then, you need to anticipate this, understand what to expect. So you either know what the expectation is for the day, or you make changes to the mix so that you can actually improve the throughput for the day. If you have enough lead time, enough backlog of orders from your customers, then you have more flexibility in terms of changing your daily production plan. Okay, I think that that is what we wanted to demonstrate in this brief example.
Didn't get a chance to demonstrate because, again, only 1 hour and 5 minutes, we need to say goodbye, is that under the result...
Let's get into a demo of the actual tool. Sorry.
Under the results, there is the data page that you can download, and it'll show you station by station the performance of the line.
Yep. Okay, so the flexibility you have on a day-to-day basis is somewhat limited, right, as a planner. So there are basically two control points to change the performance. One is to add resources, and those resources are going to have to be people for the most part. You're probably not going to add machines, but you can add people or take people away. So that's one control point you have. And the other one, of course, is this idea of sequencing, the order of production. And this is where Toyota spends a lot of time every day, is on the sequencing rules and the sequencing plan to make sure that they have the right mix of products to stay within that target range that they want to achieve every day which is in their case the same number of units every day. But sometimes they're going to be over, right? And sometimes they'll be a little bit under. Okay, so just a couple words on sequencing rules. These are guidelines for the production planning group on how to structure the order of products. And these are the sequencing rules are developed with your simulation model as a big help way up front, because you can test all kinds of combinations and come up with the optimum sequencing rules using the lean design simulator or any simulation tool. And of course, you have your real world experience as well that tells you what products typically would go together well. And this is something, again, that doesn't go away. It's something that needs to happen in every production plant every day. And just to give you an idea of what some companies are struggling with, Toyota Material Handling has over 50 base models, not including the options, but 50 base models that they combine on their main assembly line that they have to plan for on a daily basis. And if they didn't do a good job doing that, they would have a lot of issues, right? A lot of problems.
And their main driver is work content time. For some of you, the main driver may be color. For some of you, the main driver may be export versus domestic, right?
Yep.
The sequencing rules are the business rules that you're going to use to figure out the order in which we're going to release orders to the line. And it's going to depend on your business environment. But again, for illustration purposes, the folks at Toyota their primary rule is work content time.
We're now at 12:58, Gerard. So I guess we'll just keep on going. And if you all can stay a few more minutes, we'll probably run over a little bit here.
Maybe 5 minutes or so.
Yeah, we can skip this one. All right.
So in the short term, day to day, you have to primarily focus on the sequencing rules and on adding labor resources. That's it. But in the longer term, going back to a point we made before, and that is Kaizen, you can apply all these balancing tools, the elimination of waste, and in this order, right? Because it goes from simpler to more complex, the elimination of waste, relocation of work, addition of a use of IPKs, addition of resources, whether people, machine, pieces, right? Or inventory and time, which is a higher number of in-process Kanbans, or you can call it a buffer, or you can call it a FIFO lane, but that requires also the addition of time on the upstream and downstream side, and then the sequencing rules. That is more of a Kaizen type of approach to continue improving and polishing the quality of your line design.
Great. All right. So we're getting close to the end here.
That seems to be it. So again, as the mix of product changes, throughput can change. And it depends on how you choose to run your line. As we said, the folks at Toyota, they go by the number. They need to get the number. But then again, they have advantages that not everybody have. They can pick and choose from their very long portfolio to put together a mix that will allow them to get that number every day. Some of us run differently. We run to consume the minutes and not to reach a specific volume, right? Using simulation model-based planning is a way to provide you a buffer between the actual plan and the running of the plan. Is testing in conditions as close to real world as possible, right? That will allow you to test your production plan. You can make adjustments. The idea is to make adjustments to the mix and resources to improve your daily performance and reach that throughput. You don't have to run the line like the folks at Toyota. They want their 175 every day, and 175 is what they get every day. You may have a mix such that on certain days you make the choice to load the line with higher work content product and get less volume but consume all the minutes, and on certain other days load the line with lower work content product and get higher volumes. That is going to depend on how to choose you run your line. There is no right or wrong way.
Okay, so I think that's it. Here's our direct contact information. If you have any other questions.
Yeah, we're always one email away, one call away. Let us know.